Welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze the D type anchor shackle for its thermal analysis. We are going to use steady state thermal module for its analysis. We will use alloy steel as the material and also stainless steel for comparative analysis and finding out what would be the maximum temperature and what will be the maximum heat flux over the body. Now, this kind of an anchor shackle will be subjected to a maximum temperature of 204 degrees Celsius. This is as per theory, and the negative temperature is minus 40 degrees Celsius. So we will see how to find out the thermal analysis of this shackle. Also, you need to note here that these shackles will be subjected to a convection of air only. There is no other type of convection possible. So we will start by double clicking on steady state thermal. First we'll go to engineering data. We will add the material of alloy steel. Here we need to give the property of isotropic thermal conductivity. If you refer the website, the value of thermal conductivity is 52 watt per meter Kelvin. So just change this to watt per meter Kelvin. This value is 52. Also, I'll add stainless steel for comparative analysis. So this is also added. I'll go back to project and update the project. If you want to see the materials which have been added, you can just go to engineering data and just unhighlighting this. You'll figure out that these are the three materials which are now available for analysis. Structural steel being the default material of ANSYS. This cannot be changed and you cannot do anything about it. But if you directly go and refresh the project, then structural steel is going to disappear in the first case when I had chosen update project. So you can also use that option, but I always prefer using update project so that whatever material we have used in the past or maybe any material which is chosen, I'm going to just keep it as it is. I'm not going to change it. So the two materials added now are alloy steel and stainless steel apart from the default material of ANSYS, that is structural steel. So once we have added the engineering data, I'll go to geometry and right click. I'll import the model of D shackle and then I'll go to model and double click on it. We'll first go to geometry. I'll hide the shackle pin. I'll go to the D shackle and I'm going to change the material initially to alloy steel. Next I'll go to mesh and I'll change the sizing to fine and update. Next I'll go to steady state thermal and I'll insert temperature at this end. The maximum temperature that it can be subjected to is 204 degrees Celsius. Also, I'll insert convection factor over the entire body. So I'll choose entire body and select the entire body and apply. Here I'll give the value of convection coefficient of air as say 0.032 watt per mm square degree Celsius. Next I'll go to solution and I'll insert thermal temperature. Also I'll insert thermal total heat flux. I'll go to solution and solve. So this is how you can see the temperature variation over the body. You can animate and check the result. You can see here at this zone your heat transfer is maximum and in this zone you find the temperature is the least. We'll check the total heat flux. As you can see here, the maximum value of heat flux is 10 watt per mm square, and the minimum value is 2.12 into 10 raised to minus 8 watt per mm square. You can also check this result by animating such that you will figure out where your heat flux is more. Next, I'll change this material to stainless steel, and let's solve and check once again. You can see here this highest temperature has increased a bit. It has become 208.91 degrees Celsius, and the minimum is 19.893 degrees Celsius. You can again animate and check the result. There is a slight variation in these values over the shackle, and when you see the total heat flux, you will see that it is 6.8987 watt per mm square. For alloy steel, it was 10. So more heat was lost to the ambience as compared to stainless steel. Minimum value is 1.4222 in 10 raised to minus 10 watt per mm square. So with this, I end the session. I hope you have understood how to analyze the shackle pin for its thermal analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.